Привет всем, кто дошел.
Hello to everyone who is here. Now in parallel, we're having a presentation of Andrei Borodina. Do you know what was the voting result? Well, gee. Okay, because everything just overlapped with my presentation, and actually I kindly asked to swap this request, so they just swapped it in half. So actually I'm the one to blame. I'm going to tell you about the PostGIS and disaster management. Do you know what disaster management is? Do you know what PostGIS is? Okay, thank you. PostGIS? You know what PostGIS is. Thank you for coming here. Well, what version of PostGIS do you use? Great. You have PostGIS and you know what it is. That's good. Well, who am I? I am Darafei Praliaskouski. I'm writing PostGIS. My name is spelled this way, and if you mix it up, so in Russian using O, in English A. So this is the specifics of Belarusian people. So I actually do maps. I've been doing maps since 2008, and actually I do PostGIS mapping. Mapnik. Do you know what Mapnik is? If you need to have, if you want to render something strange, you can come up to me. I know a bit about satellite imagery, drone 3D imagery. If you're interested in this and you have a drone, if you want just to shoot your residence, you're welcome to come up to me. Mobile device positioning. If you have bad telephone and you have a nice taxi service and you want it to be, and if you want that positioning be operational, you can come up to me and I'll tell you. The plan of this presentation is very simple. So it is in the name, PostGIS and disaster management. As for PostGIS, the previous PostGIS I was talking about 2.5, but I was actually doing it 6 months before the release. That's why some changes took place. And now we are right in the middle release cycle of PostGIS. That's why I can tell you what we have and what we are going to have. And then I'm going to tell you about disaster management, and we'll learn what it is like and why it is different. And then we're going to go to a restaurant all together. So, the previous releases we had, the following. I had this slide. It's like in a bloody color showed what problems we had in Postgres. That, well, I spent a bit in resolving these issues, and it took me another 6 months to recover. And if you created a table and then made a vacuum over it, then vacuum will actually process complete table. But if you are in Amazon, then it's not free. It costs quite a bit, and let's sell it. Thank you to Alexander Karatkov, Yuri Sokolov. They wrote a patch, and starting for Postgres 11, you can switch this off. You have the parameter like this. You can actually set up a large value, and you will not have this index scan. This will enable you to insert the table and may do vacuum as many times as you want, and the speed will be significantly higher than in version Postgres 10. I also had another slide. What I need to have to be happy. I always miss something to be happy. It's like the way of life. I needed the clustered right. I needed a better yeast. I needed vacuum, a faster vacuum, and I needed index-only table and appended-only table. I wanted to have index-only scan. Over this year, we had great changes Well, we just completed 1.4 out of 4. We need to appreciate this. But still a lot of things to do. What? Possibly we are going to have more science at the next Postgres conference, PostGIS 2.5. I've already told you a lot about Postgres 2.5 last time. You can actually watch a video. So the thing I lied a bit is the process in invalid geometry. So PostGIS 2.5 got committed the simple silent correction of non-invalid geometry, but then they decided to make a difference before the release, because a lot of people say that we cannot work like this with invalid geometry, and we rolled back because it's a minor update. Everything else works, everything else was committed. Wow. So I can explain you based on this picture. We have a new way to interact with geometry. If you had a curved line, jerked line with sharp turns, then you can make a sharp straight line. Just set it to state shake and smoothing and becomes nice and fluffy. How does it work? All the segments are split into 4 parts and the edges cut. They are cut in iterative mode, so you can actually set the number of iterations, and in principle you get close to a line. The next thing we added is the oriented box. On default in PostGIS they are all oriented by axis, but for many people this is unexpected, and when they look at the boxes they want them to be turned depending on the figure. If you have some triangles or rectangles again, so you just wanted it turned rectangles, we have the function that is able to calculate this. So quantized coordinates. Did you have that when you just were missing a few kilobytes in order to store something to disk? Just a few kilobytes. So we had this story. One time we identified that we had a parallel presentation, the way we deploy with Docker. And it turned out to be that in Amazon, the intermediate layers in token may be no more than 4 gigs. And we just were not able to squeeze into it, but we found out if you take the quantized coordinates function, that the file with data, when you apply this function, so the zipped file will weight considerably less, because a great amount of everything in there becomes zeros. And if you know that you have only 4 figures valid, then you don't have to store all these bits. You just nullify them. Our PGLZ that actually applies automatically by Postgres will actually compress the data, and it will make it much better.
Немножко про PostGIS 3.0.
Now a couple of words about PostGIS 3.0. So, there are things you've been dreaming about for many years. Some time ago, PostGIS developers decided, what if we release PostGIS 3.0 and there was a to-do list with a lot of items what we are dreaming about. And here we have a couple of new developers and they said, what if we release it? It was very unexpected for those old school developers who believed it would never happen. We will spend 2 years, then we will do something in 2 years. And they just started to release it. It's a major update. In PostGIS there are a lot of things that we would like to change. Architecturally they are not implemented correctly. I call them breaking fixes, because they break the behavior, but at the same time they fix some abstractions. Out of these things that happens in PostGIS 3.0 entirely. Now in PostGIS you can switch the geometry processor. We have GEOS and we have FSeagull engine. We benchmarked it, we took a while, and we decided to discard FSeagull, because we don't as FSeagull we don't need it. In 2D, it uses the same engine that it uses for 3D processing, so it's a slower process. We just decided to remove it at all. There are a lot of projects that after taking a look at PostGIS 3.0, they found a library, and it was like a side effect. They wrote a test, they had to allocate something to a library that can connect to tests, not to Postgres. This library was put into a file system, it was found, and based on this library they built some piece of software, and internal PostGIS interfaces became external interfaces of PostGIS unexpectedly for PostGIS developers. It led to very funny consequences. Some piece of software just stops working when you update PostGIS. At the same time, we didn't promise anything to anyone. Some people used it, and some people just made their commitment, but you can't afford making this. So starting from PostGIS 3.0 we decided to remove this library as installable one. But let's take a closer look. There are forks that you can use, and they are providing you with a more stable interface, and it's called Liberty. Apart from this, we have very decent features. If you are not familiar with this feature, there is a way. If you know Mapnik, you know that we have raster tiles, BIP tiles, and also there is the same way to store vector. Orbica committed a patch for feature ID. It's one of the ways to store geometry ID. It was processed by PostGIS and sent then to the final result. Now with PostGIS we can generate layers of bit tiles, and they allow you to scroll over with your mouse and then to show something in a separate table, because the process engine can give it back to you, and then it allows you to show this data somewhere else. And actually this streamlines the whole process of working with geometry, because we have to make interfaces, and the only way to show large-scale geometry is MBT. You can't have a JSON for every browser. MVT can do it easily, because it's a binary feature. Esteban. Let's wave to Esteban, because he committed a patch on n-dimensional SPGIS. Now in PostGIS we have it. Tomorrow there will be a presentation by Esteban who will tell you why he decided to make it. Well, this is not purely about PostGIS, it's a thing that I have found this year. So the main problem is when you don't have GIS data, but you are willing to work with it just to get yourself familiar with this and to manipulate them. You would like to have some data in Postgres and then to do something with them. And this process is very painful. It's just petrifying, not just complicated, it's petrifying to write a command with configs, with something. Now it became as much simple as possible because we have osmium command since version 1.10, and it can make output format PG. Use just say I would like to export file data / planet latest OSM PBF into PG format, and that's it. The main problem was everyone was trying to make unstructured OpenStreetMap and to make it like structured data, to have columns. And we say, why are you doing this? Because in Postgres we have JSONB support. And it makes the table structure very simple. Geometry and text JSONB. After this export, you create two indexes, one for geometry, one for JSONB text, and it's very simple, it works. Now a couple of words about problems. It's a brand new approach towards data processing. It looks like that Osmium is fast itself. 40 gigs planet can be processed in a couple of hours and then converted to CSV, so I could use it in Postgres. Then Postgres JSONB parser is slow, and then Gene index is being built very slowly, and then it takes 9 hours to build GIS, and this can be accelerated in Postgres. So if you are bored and you wanna see what can be accelerated in Postgres to make it faster than Omnium, you can use unstructured data processing in JSONB. You just import OpenStreetMap, a small 40 gig file that in 12 hours will be converted into a table with 2 indexes, and you will have an opportunity to see what's inside. Another thing that is happening right now in PostgreSQL world is inlining. Anyone knows what common table expressions are? Common table expressions will support inlining in PG12. Now that doesn't support inlining. They are optimization barrier. PostGIS has another problem. There is only one way to use Postgres indexes, and it is to make an operator accelerated by an index. But SQL standard for geodata defines that functions must be used for it. That is why somehow you have to match functions to operators, and the only way that PostGIS found is to write a small function that calls for operator, and then to write a big fair function. And it works. It works well until inlining decides that it's time to stop inlining your function, and then indexes stop working in your queries. What can we do with this? You go to PostgreSQL hackers, you see threads with Tom Lane and Paul Ramsey and me. And then you write your feedback that is very important, it's very serious, and in row number 12 there is a typo or an error. Before we proceed with disaster management, I would like to know, do you have any questions? Okay, I'm all ears. Darafei, tell me please, you showed us that we can save some space by cutting off unused characters. So eventually, is it just because you can't upload the file, and finally, eventually, do you keep it like this? You know that input data, very often, only 5 numbers after the comma are correct. It applies to all data sets, all geographical data sets. So we all know that they store in timing, so only 7 numbers after the comma are relevant. And then these are just nulls or fixed points, it's just mathematics. And when we try to store it, to save it, it keeps all 15 numbers. And we can just reset them. We can turn them into zeros. A couple of words about disaster management. Well, I was walking around and I was asking what is disaster management? This is the topic I would like you to keep in your minds if you are Postgres developers. I'm not going to tell you how PostGIS can be applied for disaster management, because you can find this information in manual. It's all about polygons overlapping, proportions of surfaces. It's very trivial, but still there are external implications that exist and that oblige you to think in a different paradigm. So what is disaster management? The first option, so it's when your manager is a complete disaster, and this is the way how they manage you. But it's not about this. Second opinion is that we back up all our virtual machines. So guys, your disaster plan, if for example you have a data center and there is an outage or someone made an error in sudo command, well, yes, it is disaster management, but it's a very technical aspect of it. Someone said, so disaster management is when everything explodes, gets on fire and falls apart into pieces. And in fact, this is the correct definition. When everything blows up, gets on fire and falls apart, you need to make something out of this mess. So in disaster management, there is a term which is called event. It's an event itself when a disaster happened, like a tsunami, crash in Thailand, and it turned out that all factories on Thailand hit by this tsunami were producing HDDs. After this, everybody turned to SSDs, so they started to migrate to SSDs until these factories went back. But they realized that SSDs are cheaper and more efficient, and they stopped producing HDDs. There are certain cases when earthquake hits, and sometimes people are just waiting for it. When you live near the volcano and you are waiting for the eruption, and you are waiting for it and you are getting ready for this. But how can everybody get ready for the eruption? For example, you are living in your house near a volcano, there is an island, and there is nothing in the distance of thousands of kilometers, and the only way is to run towards airport and then to fly away from the eruption. You can't float, you can't sail away. For example, on Hawaii you can't sail because you are interfering into whales' life. This is what they decided to prohibit on Hawaii. So there is a stage which is called pre-event. It's something that when everything is good, and the vast majority of people don't even think that something may go wrong, at this moment the entire disaster management process is renamed to risk management, just not to make you frightened. Risk management or something management, and everything is okay, everything is good. Do you understand why why we do it? Yes, to manage. We understand why we rename it, because it's not okay to make you feel afraid. There is a huge organization like World Bank. They have a lot of money and they have a problem. They can't put this money into another bank because they are the biggest bank in the world. And the only way for them to save this money is to invest into something. For example, into someone's economy, as they are hoping they can invest it for hundreds of years, and the return of investment terms, they're not relevant, because all they need, this is their last resort to invest some money just to have something back one day. A very interesting project starts. What if we make our houses warmer, and then the warmth that we save, we will calculate it. Well, all houses will be reinforced, and then you will make us. You will return some money to us, but that's okay. And in 100 years, it will be covered, and it's okay. So at this stage, everything goes very smoothly, because everyone knows CAP theorem, consistency, availability, and partition tolerance. And you don't have any partition at all. Internet works. You can use available system, and it is consistent. If internet breaks up, well, we will switch to 3G just to have our internet connection back. You can deal with it in a very easy way. So the questions are: who do we give money? Where do we invest and wait for returns? What may happen to them? How can we save them? And what's, in fact, our plan? What can we do if it happens that some things are going wrong? Do we have time for it? For example, there is a system that is dealing with this, and it calculates indicators for it. It's called GeoPioneers, and they are calculating all conflicts, like attacks, like ethnic clash, something else. And by this, you understand that something bad is going here and here. In Vietnam, for example, something is going bad on the border between Nigeria and Chad, and this is not the right country to invest. But you can go to the government of relevant countries and say you have problems, and the problems are like this, and if you solve them, we will start investing in you, probably, because we need to have our investments back.
This is European Staff Inform Index for risk management. This is a large table, includes all countries, and it says that this country does this. It has so many percentage of this stuff. For example, so many hospitals per 1,000 people. All the parameters are in there. And actually, you get the rating, the conditional rating, just to compare when you can take two different regions and compare it each other, what you can fix here or what you can fix there. There are no targets and goals to achieve specific or absolute 10 or the top 10, because if somebody reaches top 10 in everything, then the task of index constructors is to make up any type of indicator so you can differentiate them from all others, because they rank their regions. In general, this is all what happens before the event. Everybody repairs, fix roads, warm up houses and buildings, acquire aircraft, and so wire fiber optics. And then all of a sudden, something unexpected or expected happens, called event. And here, this picture from Haiti, 2010, shot by Google drone. It's just a sign on the roof. People are dying, and they just crash on the roof so that somebody rescues them. In order this not to happen, there are some people who actually do the disaster management, and they plan at least a specific plan for this type of situation. Question number 1. When we get any type of emergency, there are about 20 emergencies every day. You have a feeling that it doesn't affect you, but in every part of our world happens something, the hurricane, tsunami, or something else may happen. And the first question we have, do we need to do anything with this? Can we help in any way? Or, for example, the car is blown off, they can actually pull it out. We don't have, to fix the car in Great Britain. The next thing we have, everything falls apart. All infrastructure you invested stops existing. It's actually the definition of a disaster. Everything you actually based upon or relied on is not there. Maybe it's here, maybe it's not here. We are not sure. And we believe that it may disappear one day. If you had a laptop with you, so you can actually believe that if you're intact, then the laptop is intact as well. But the cell phone base station and fiber optics to this base, the contract coverage, it all may go in vain, and you will have no partitioning. Everything will fall apart, everything you do. And in case of database and information system, we have to go by the fact that you already have partition, that you need partition tolerance, and you need to choose whether you're going to sacrifice consistency or you're going to sacrifice availability. Everything you can do. If you're a regular person, you will continue choosing consistency and your system will go down. If you work in disaster management sphere, then probably this is exactly the moment when your business day becomes 12-hour long, 6-hour, 16-hour long, or 18-hour long. You need to fix everything, but nothing works. And you select availability. You believe that at least something shall be working. And if your cluster falls apart, and that was a multi-master, you need to write anywhere. There is a nice system that resolves this. If you don't know where to go, where you need to design the system that will work in an absolutely unpredictable way, just look into a Dropbox. It really resolves so many disaster management projects. You may just have a feeling that it just synchronizes files. But this system can coexist in LAN. You just plug it into a laptop or any type PC with a shared folder and start syncing. You launch. You just put the file into a folder and everybody gets access to it. This is highly valuable. If sometime, and the problem is that this exists at user level. There is virtually no server level. There is no server that actually it is not appropriate to install Dropbox to the server, but we shall do this. You need any different system that will not be Dropbox but will have the same properties. When you actually plug in the LAN, the only one remaining and the only remaining server that works on the last UPS, the monitor is cracked and everything else is the last laptop, you shall have the ability to pull this data out by the only cleaner that is there. So, the data stops being snapshots. It's just, like the live population data, they becomes the live data. all data becomes love. And instead of using all population data, you come to the company, let's say Facebook, and asking, tell me, where did you see people for the last time? Where shall we go? Where shall we sail to? Or mobile operators, how many cell phones were active in this base camp? Please tell me something, because at the moment we have no idea where the people were this moment. At the moment, people don't have any connections because they don't have any electricity, power supply, or anything else. But if they survived, they help a lot. Do you know why we send SMSs like this? Strong wind is going to be there. Do you know why they do this? Do you know they want to warn you? Now, okay, to get some money, it's okay, but the one thing is the idea of the SMS. When your phone gets SMS, it actually reports in the base logs, and everybody knows where you were this moment. You have the exact snapshot when you received this SMS in what base stations you were registered in. There are some pictures from drones. You're flying above something, you shoot. And instead of using Google Maps of 2-year-old, you start using a 5-minute-old data. Reports. Somebody reached the hotline saying that there is a school bus, that something happened with. This is much more valuable than any other type of information because this is the ready-made analytics. You know what to do. And if you have this, then you can do this. And the maps, instead of the snapshots, you become the minute-wise updates. So, for example, in case of emergency, HOT is the company that actually, and it's not the Postgres HOT update, it's a different HOT update. This is Humanitarian OSM OpenStreetMap Team, who actually is their organization that unites volunteers, or in case of emergency, that happen 20 per day. During the lunch break, they open up special interface, select whom they want to help this time, and start drawing a map where, so in the areas they miss some information. But after following the event, after everything is resolved, everything gets back, everything in pre-event. You're thinking about everything. You're thinking the way to save everyone. Thank you. Are there any questions? Yeah, I just said it from the very beginning. So the question, where is the Postgres in disaster management? The main use of Postgres, as Postgres works on the Postgres base that is consistent. At least mainly in pre-event. In the event itself, as partition tolerance in Postgres is very little. It lives in the moment when you need to make a map and find out how many hospitals are in this region. You take a snapshot of a map, you take the snapshot of regions, join it together. Everything is in PostGIS documentation, there are some examples. And you get a figure, a value. And after that, you can actually input into index. That is all. Thank you very much. Let's discuss it afterwards.